Let's go. Get ahead in chemistry. Chapter 6. Electro-chemistry. Okay, let's just get this started with it's just 20 seconds already. Electrochemistry. Electrochemistry is chemistry with electricity in it, and it sounds simple. It's way more complicated than it sounds like. It's not just chemistry and add a bit of electricity, no. It's what you can create with electricity and chemistry. And the most common result that comes out of this is batteries. We have coin batteries, these small dry cell batteries. Also, this is a new one. And giant dry cell batteries too. And these are Bexel ones. And these have a lot of power in them, baby! And if you put two wires to them here and connect them, you basically created yourself a circuit. If you pass a little light bulb, if you put in a little light bulb here, then the light bulb will get electrified and light up because of how it works. Thank you, Thomas Edison, for that light bulb discovery. I'm gonna grab this battery for the rest of the video because I love batteries! Especially the ones that are colored in rainbows, but hey, I like bigger batteries too. Now get ahead in chemistry, electrochemistry. Electricity itself is an interesting property. It's created by electrons flowing. And because of that, there are two things that you should know. There's a cathode and an anode. An anode is basically just the negative side of things that attracts positive ions of stuff. And a cathode is just a negative charge and it attracts positive stuff. And the thing is, you can use that to separate stuff out together. But first of all, we need to learn how a battery works to know how to use electrochemistry. Now, a battery works like this. As you can always see, there's always a label on one side of the battery that has a plus side and a minus side. Now this is actually really important because it depends on how you put this that makes the circuit go. If you put it in the wrong way, say you're supposed to put it like this, but you actually put it like this, then the circuit will just short circuit because you're supposed to go this way, but the electrons there are now being forced in this way and they're colliding each other. And that is not useful at all. And that's not how a battery should work. Now, inside this battery is a kind of paste. It's that paste that prevents electrons from leaking it out, and it's also the thing that powers the electrons too. And the good thing and the old way you can create a battery is that you used a liquid version of the paste, but then they realized, hey, it's not so movable. Hey, let's just turn it into a paste, and then they created the battery, which can be removed, thrown away, and replaced with a new one. And nowadays, you can even have these small kinds, which are not as efficient, but are really, really, really portable and come cheap too. They're really cheap compared to a bunch of these. Well, they're not that cheap. They are more expensive than I just told you. But if you're just buying one of these compared to buying one of these, yes, this is cheaper than this. Not by much though. They do about the same amount of energy. In fact, these would give the same amount of energy. It's just that how many electrons and how many volts it gives are here. In fact, I'm pretty sure this one is the 1.5 volt. In fact, these two batteries, well, just imagine there's only one of the coin batteries, actually give out the same amount. Each of them give out 1.5 volts. Well, 1.5 volts of electricity. See, it's written right there, and here, the 1.5 volts is written right here. It always shows the voltage. And that's why batteries are limited, and in the future, we might even be able to make rechargeable batteries that charge just by us moving. Imagine being able to charge your phone with it connected to your backpack and just because you're moving. And of course, using that portable battery as principle, we've been even able to create portable chargers, which we can use to charge our iPhones. Let me show you. Charger here, and then connect. Yep, it works brilliantly. What is going on right here? And that's not it. While this thing is charging, loads of things will start happening. Because this thing, by charging it, it just redistributes the electrons to its original state. It's making the electrons move backwards until this thing runs out of power and we need to move back the electrons to this thing. And it's really useful too. You can charge anything with chargers as long as they give out enough volts. And that's electrochemistry for dummies. It's basically how you create batteries, how to conduct electricity, and how to make things move. Like Frankenstein, but smaller. And that's it. Hope you guys enjoyed this episode, and I'll see you guys soon. Until next time, Sean out. Meow. Bye.